Today we're looking at adding and subtracting fractions. So just some things to talk about before we look at what we're going to do here. So a key word for today, or keywords, common denominator. So we've probably heard of the word denominator before when we talk about fractions, and we probably know the word common from everyday use. But specifically to maths, a common denominator is when the denominators, or the bottom, of two or more fractions have the same number. Okay, so we're going to look at some examples of that in a second. Maybe write that down if you weren't sure on that before. But task one, we're going to look specifically at these common denominators. So what I want you to do, I want you to make the denominators of the two fractions equal by converting either one fraction or both of the fractions to an equivalent fraction. And what we mean by equivalent is a fraction that is exactly the same or an equal fraction. So for example, a half might be 2/4. So if you haven't written that quite down yet, maybe pause the video. You can write it down and then we can get on with some examples. If you have written it down, or at least the key parts, let's try example one. So example one. And we've got 3/8. As we said, we want to make these have a common denominator. Now at the moment you can see the denominator for the first fraction is 4. The denominator for the second fraction is an 8. So they're not the same number. Okay, remember our keyword definition. We want the denominators of two fractions to have the same number. So the first thing we need to think about, can we make this 4 here the same as the other one? So we're going to look at the smaller number. Can we make it the same as the bigger number? And actually for this one, we know that 4 does go into 8, don't we? So how many times does 4 go into 8? Think about your 4 times tables. 4, 8, that's 2 times 4. So if we multiply this fraction by 2, which means the numerator and the denominator, we're going to get an equivalent fraction to 1/4 that will have a denominator of 8. So 4 times 2 gives our denominator of 8. We need to multiply our numerator by 2. So our numerator is 2. Yeah, so now you can see we've got two fractions. So 2/8 and 3/8. And they share a common denominator because the denominator is 8 for both of them. Okay, so hopefully that example made sense for us. The next example, I'm going to give you the fractions, and I'll give you a little bit of time, so maybe pause the video and you can try it yourself. Okay, if you're a little bit stuck, look back at what we did in the first one. I'll give you maybe some hints before you go and try as well. So example 2. We've got 2/5 and 7/15. So I'm just going to give you a couple of reminders. Remember, we're looking at this smaller denominator at the moment. Does 5 go into 15? I know that it does. Can you work out how many times? And then from there, can you repeat the process we did in example 1? So how many times did 5 go into 15? Multiply your numerator and your denominator of 2/5 by that number. Okay, so pause the video here, have a go at that question. We'll talk about it in a second. Okay, so hopefully you've had a go at that. Now we said, how many times does 5 go into 15? So if you count your 5 times tables, you might already know. 5, 10, 15, that's 3 times 5. So we're going to multiply our numerator and our denominator by 3. So 2 times 3, our new numerator is 6. 5 times 3, we know that gives us 15. So 2/5 is the same as 6/15. Let's make it nice and clear what our final answers are. So So we've got 6/15 and 7/15. Yeah, there are two equivalent fractions, 2/5 and 6/15, but 6/15 have a common denominator with 7/15. Okay, and we need to be able to do this in order to add or subtract fractions. Okay, we're going to look at two slightly harder examples as well. Again, I'm going to talk you through the first one, and you can try the second one. Then we're going to put this into practice alongside some adding and subtracting as well. So example 3. Got 1/3 and a half. Now, we said before, we need to find whether 2, the smaller denominator at the moment, goes into our larger denominator 3. Now, 2 does go into 3, but not a whole number of times. So if it doesn't go in a whole number of times, we need to do something different, because we don't really want to work with decimals here. That's going to maybe confuse us. It's going to make things a little bit harder. So let's think, what number could 2 go into that 3 also goes into? So really what we need to do is write out our 2 and 3 times tables. So if we write our multiples of 2, 2, 4, 6, 8, if we need to go further, we can. But let's try our 3s first as well. So 3, 6, 9, 12. Are there any numbers here that match up? So they're in the 2 times tables and the 3 times tables. You can see here, look, 6 fits into both. So we want our new denominator, sorry, to be 6. Okay, so we're going to say our common denominator will be 6. Okay, now you might have noticed if you look at your 3 times tables, there's a 12 there as well. That is in the 2 times tables. So we could have had a common denominator of 12. So any number that's in both the 2 times tables and the 3 times tables could be our common denominator. Yeah, in this case, we've gone for the lowest common multiple. Yeah, so the lowest number in both times tables, which is 6. Another thing you could do is just times this one by 3 and times this one by 2. Yeah, so multiply each fraction by the opposite denominator. Okay, so we know we want the fractions to be out of 6. Now what we need to think, we're going to do something different to each fraction, so be careful here. We're not going to do the same to both fractions. So we need to see how many times 3 goes into 6. So if we know our 3 times tables, we've written them here. 2 times 3 gave us 6. So we've done our denominator. Let's look at our numerator. 1 times 2 equals 2. So our first fraction would be 2/6. Then we need to look at our second one and look how many times does 2 go into 6. We'll look at our 2 times tables. It was our third multiple. So 2 times 3 is 6. And so 1 times 3 gives us 3/6. Again, we can make it nice and clear. Our first solution was 2/6. And our second one was 3/6. And they are 2 fractions equivalent to the original fractions that now have common denominators. Okay, so we'll try example 4. And again, like we did with example 2, I'll give you a little bit of a hint. Let's see if you can follow what we did in example 3. If at any point you're a little bit stuck, by the way, feel free to go back through the video, listen to example 3 again. Yeah, obviously that was a little bit more complicated than 1 and 2. But example 4, we've got 5/7 and we've got 3/8. So we need to get them to a common denominator. Okay, And just our initial reminder, need to do our 7 times tables and our 8 times tables. We're just going to start us off with our 7s and start us off with our 8 times tables. So have a go at this one. Keep going through your 7 and 8 times tables until you get a number that appears in both. Okay. And then if you can you convert both fractions to an equivalent fraction in which both would have a common denominator? Again, pause the video here, have a go. If you're not sure, we're going to talk about it in a second anyway. Okay, so let's continue our 7 times tables. And at this point, I'm just going to add one multiple to each, both times. Okay, just remember you're switching between 7 times tables and 8 times tables. If you prefer, just do a long list of 7s, a long list of 8s. So I'm going to keep going, just checking each time. Have I written this number in the opposite column? Still going. Okay, 49, close to 48, but we're not quite there. Okay, it's still going. And look, suddenly we've got two numbers that are the same. So 56 in our 7s, 56 in our 8s. We might recognize that 7 times 8 is 56. So again, that's a little shortcut we could do. But if we prefer to do it like this, that's fine. Okay, for the purposes of us doing it for the first time, this might be a little bit more helpful. Okay, so again, we've circled our common denominator. So that's what our fractions need to end up with a denominator of. So I'm just going to fill that in straight away, 56 and 56. Okay, now we need to think, how many times did our 7 go into our 56? So if we look at our 7 times tables, 1, 2, 3, 4, 5, 6, 7, 8. So we need to multiply our numerator by 8, so 5 times 8 is 40. Okay, then think about our denominator for our second fraction. So 8 into 56. 1, 2, 3, 4, 5, 6, 7 times. And again, you'll notice, look, we've multiplied by 8 for the first one. That was our denominator on the second fraction. Multiplied by 7 on the right-hand side, and that was our denominator for our first fraction. Yeah, so there's that kind of symmetry there. Okay, we need to do our numerators. So 3 times 7 gives us 21. Okay, and again, we're going to make it nice and clear. Here are our equivalent fractions to the original ones, and we can see they share a common denominator. So that's what we're trying to achieve every time with these questions. Okay, so feel free to stop the video here, go a little bit through them if you were slightly confused. Yeah, they did get a little bit harder as we went on. Okay, if you understand the basic principle of what we're trying to do, that's the most important thing here. We're going to keep practicing it when we do some more examples. Okay, but for now, we're going to move on a little bit, and we're going to try and add and subtract some fractions as well. Okay, so I'm going to give you a moment to write some of this stuff down. Let's talk about it. So when we add and subtract fractions, first we make sure both fractions have a common denominator. Now we should be relatively confident with that part. Yeah, we know that that's what we need to do, and we've had a little bit of a practice at them. Yeah, we're still going to practice them in this process. It's part of the adding and subtracting process. Okay. Once we've done this, we add the numerators together, but the denominators stay the same. I'm just going to say denominator stays the same because we're going to end with one fraction. Okay, so again, let's talk through some examples. So example 1. Got 1/7 plus 5/7. Okay, now if we look carefully at these two fractions, we'll notice already something that they have in common. Okay, and remember our first step, we need to make sure both fractions have a common denominator, and it is in this case the denominator that is common. So they both have that 7 at the bottom, don't they? Yes, they're on the denominator. Okay, so we've actually already done step 1. Yeah, we don't need to do anything else to our fractions. Okay, we don't need to make equivalent fractions or anything. We can just now find our final answer. So remember, we add the numerators together. So 1 plus 5 is our numerator. Okay, you might know what that is already. I'm just showing my full working just for our first example. And then we said the denominator stays the same. So we've got our 7, our 7. So this denominator stays the 7. We don't put 14. Okay, and then finally, 1 plus 5 we know is 6 out of 7. Yeah, and if you want to use colours to help you link certain parts of this, that's absolutely fine. Definitely helpful. And again, I'm going to use my highlighter, and I'm just going to show that 6/7 is my final answer. So it's always good to make your final answer clear. Okay, so that was a straightforward example, but we need to be aware sometimes we don't need to do that first step where we change the denominators. Okay, sometimes the denominators are already the same for us. Let's try example 2. This one we will change some denominators. And I'll give you a chance to see if you can work out those denominators first. So we've got a half plus 2/4. Okay, so let's see, first of all, can we change one or both denominators? Okay, to make them common denominators, remember to do whatever you do to your denominator, do to your numerator when you're finding an equivalent fraction. Okay, and then maybe if you understood example 1, could you add those two fractions together? Okay, pause the video here, have a go at them, and then we'll talk about them in a second. Okay, so I've put the arrow underneath a half because I know if we look at the denominators, 2 does go into 4 a whole number of times. Okay, so our denominator will be 4. We can have 2 common denominators, which are both 4. Now we need to think, how many times does 2 go into 4? Well, 2 times 2 makes 4. Okay, and then 1 times 2 gives us 2. So actually, look, these two are the same fraction already. So a half is the same as 2/4. So there's the equivalent to this first equation, except this time we've got 2 fractions with a common denominator. Let's go with our green to add the numerators. Remember, the denominator stays the same, which means our final answer, 2 plus 2 is 4. Denominator stays the same, so that is also 4. So this could be correct, or 1. In brackets, I'm going to put whole. Yeah, because we know, think about the pizza slices. If you have 4 slices out of 4, yeah, you've cut the pizza into 4 slices, and all 4 of them are still there. You've got the whole pizza, haven't you? So there's our answer. Either of those are acceptable at the moment. Okay, A couple more examples, and then you can practice some yourself. So example 3. Let's try a subtraction this time. So 2/3 minus 1/6. I'm just going to rule underneath here. So we don't get too mixed up with example 1, 2 and 3. So again, like we did in example 2, can you change one or both fractions to an equivalent fraction so that both have a common denominator? Okay, and then try and do step 2, but instead of add the numerators together from our example, we're going to then subtract the second numerator from the first numerator. Okay, remember, denominators still stay the same. Okay, so as usual, pause the video, have a go, and we'll talk about it in a second. Okay, so I know that 3 does go into 6, so 6 is a multiple of 3. And to get 3 into 6, we need to multiply it by 2. So actually, we just need to change the first fraction to an equivalent fraction. So we double it times by 2. To get 6, we need to multiply our numerator by 2 as well, which gives us 4. So this equation is the same as saying 4/6 minus 1/6. Yeah, and now they've got common denominators, so we can solve it. So again, I'm going to use green, but this time instead of add, we're going to subtract. We're going to keep them in that same order. So 4, take away 1. And remember, our denominator stays the same. So because they're common, equal, I was about to say. Yeah, they don't change. And then if we do our 4 take away 1, gives us 3 over 6. Okay, and there's our final answer. Some of you might recognize as well that 3/6 is the same as a half. So if you put a half as your answer, as long as you've shown this working, that would be perfectly fine as well. So if you spotted that, well done. But 3/6 at the moment is perfectly fine. Okay, we're going to try one more example, which is a little bit harder. So example 4. So this time 3/5 minus 1/2. I'll just scroll down so we can see just example 3. Gives us space for example 4. So think about this. This time, just a little hint. 2 doesn't go exactly into 5 a whole number of times, so we're going to have to change both of our denominators. So a little clue. You might want to start trying to write out your times tables if you're not sure. Or if you can remember that shortcut we discussed, yeah, you'll be able to find a common denominator like that. Okay, so as usual, pause the video here, try and finish this question, find the common denominators, convert the fractions to equivalent fractions, which share a common denominator, and then can you subtract the second fraction from the first fraction? Okay, so if I continue my multiples, so I'm just going to continue the 2s because the 5s are already up to 15, so we might not need to do any more 5s. Okay, look, we can see now we've reached a denominator that is the same. So 10 is a multiple of both 5 and 2. So in our fractions here, we want our denominator to be 10. Now we need to look at the first fraction. How many times does 5 go to 10? That's 2. That's 1, 2. So our numerator, 3 times 2, gives us 6. Let's fill that in here. So 6/10, and then let's convert the second fraction. How many times does 2 go into 10? 1, 2, 3, 4, 5. Yeah, we've written out our list, haven't we? Okay, or we know multiply it by the opposite denominator. 1 times 5 gives us 5 as our other numerator. So what we're saying is 3/5 minus 1/2 is the same as 6/10 minus 1/10. Okay, so just like we did in all the other questions on this, I'm going to use my green. 6 minus 5 is our numerator. Our denominators are the same, so they don't change. So 6/5 minus 1/10, or 6 minus 5 over 10, sorry. That gives us 1 as our numerator. And that 10 stays the same, doesn't it? Okay, so that is our final answer. And as usual, we're going to make it nice and clear. Okay, and that is how we add and subtract fractions.